So this question here is all about solving trig equations and using trig identities. Now, we've got several trig identities that we are given in the formula list at the start of the higher paper. What we have to be able to do is effectively recognise where each of these formula come in, recognise which one to use, and then substitute and use them effectively. Now, in order to recognise it, you have to look at some sort of equation like this and ask yourself, firstly, are there two different trig functions in this? Well, yes, in this case, there's sine and cos. So what I want to do is get rid of one of those trig functions and write it in terms of the other. So I'm going to write it in terms of a function with either sine or cos. Now, the one to look at getting rid of is the one that has the 2x. So in this case, I have cos 2x here. Now, something 2x is different from something x. So if I had sine 2x, that's different from sine x. I couldn't solve an equation with both of those together in it. I could if it was one of them, but not both of them. So I want to get rid of it. Do I want to get rid of this cos 2x and write it in terms of sine x? Well, if we think back to our formula list, we know that cos 2x is the equivalent of 1 minus 2 sine squared x. If I use that in there, I'll get rid of the cos, I'll get everything in terms of sine, and I'll have a quadratic that I can solve. So let's do that. So I'll have sine x plus 2 equals 3 bracket 1 minus 2 sine squared x. Multiply out the bracket and I get sine x plus 2 equals 3 minus 6 sine squared x. Now it's a quadratic. Remember, to solve a quadratic, we want it equal to 0. Shift everything on this side across to this side. So I get 6 sine squared x plus sine x minus 1 equals 0. So I've got a quadratic written in terms of sine x rather than just x on its own. But the technique for solving this doesn't change. The only different thing is, instead of when I factorise brackets having x plus something, x minus something, I'll have sine x. So what I'm going to now have to do is recognise the type of factorising I have to use and do it effectively. So no common factor, not difference to two squares, it's the trinomial technique. Factorise this and get my two brackets. What I'll end up getting is 3 sine x minus 1, 2 sine x plus 1 equals 0. Now remember, like a quadratic, either of those two brackets could be equal to 0. So in this case, I could get 3 sine x minus 1 equal to 0, or 2 sine x plus 1 equal to 0. Now, if you look at the original function as well, the original equation, right back at the start, I'm told that x is between 0 and 360. Now, if you think of your standard sine or cos equation, between 0 and 360, if I set it equal to something, besides, for example, for cos 180, negative 1, I'm going to get two solutions. So we've got to take into account that fact here as well. I'm going to get two solutions for each of those two brackets, which means I'm going to get 4 possible solutions here for this equation. Now, if the limits were to change, I might change the number of solutions. But here, because it's between 0 and 360 degrees, I'm going to get 2 solutions for each, so I have to solve both of them and get all 4 solutions. So take each bracket one at a time and solve them individually. Because remember, the answer for the first one, so for example, the answer for 3 sine x minus 1 equals 0, is not going to affect the answer for 2 sine x plus 1 equals 0. They're two independent little functions to solve. So if we start with 3 sine x minus 1 equals 0, what I end up getting is that sine x is equal to 1/3. Now, we remember the technique for solving something like this. We involve our cast diagram. And what I'm looking at is, in this case, the function sine x is positive, so I'm going to get two answers. One falling in the A section and one falling in the S section. So to get these, I solve it. I'll take sine minus 1 of 1/3 and I'll get an answer. That answer falls in the A. Then I want the answer that falls in the S section, so I'll do 180, take away that answer to get it. So if I do x is equal to sine minus 1 of 1/3, what I end up getting is that I get an answer of x is equal to 19.4 degrees. And then to get the second answer, I'm going to do 180 take away that 19.4 degrees. If I do that, what I'll get is I'll get two solutions, one of 19.4 and one of 160.6. So there's my two solutions that come through from having 3 sine x minus 1 equals 0. Now I'm going to get two other solutions if I use 2 sine x plus 1 equals 0. So let's solve it and get that. So I get 2 sine x plus 1 equal to 0. So for this one, sine x is equal to negative a half. So if I refer back to the cast diagram again, I'll use this in a different colour to indicate this one. If sine x is equal to negative a half, I'm actually going to get solutions that fall in the t in the c section in this case. So I have to figure out how to get those. Well, separately, what I'm going to do is I'm going to solve sine x is equal to a half. If I solve sine x is equal to a half, what I'll end up getting is 30 degrees. Now, if that were a valid answer, that would be the one that falls into the A section. But it's not. That's not an answer that we're using. Hence the reason we've done it separately away at the side. What I'm going to do is I'm going to use that answer to get the one in the T and the C. Now, to get the answer that falls in the T section, we do 180 plus that solution. To get the answer that falls in the C section, we do 360 minus that solution. So I can then say, fine, so x is going to be equal to 180 plus 30, or 360 minus 30 degrees. So I'll get two solutions for that one. Nice ones actually in this case, 210 and 330. So what I've done is I've solved each of the two brackets on their own, independently and individually, and I've found 4 solutions for x in this case. So overall, let's just state them together so we've got nice clarity on the whole thing. X is equal to 19.4, 160.6, 210, and 330 degrees. So that there is the 4 solutions that exist for that equation between 0 and 360 degrees. And if I were to plug any of these in for x, what I'll find is that it works out. So this question has required a little bit of work, and it's brought in several techniques, including skills from National 5, such as working with quadratics, and then skills from way back in S1 and 2 mathematics, solving simple trig equations, so 3 sine x minus 1 equals 0, or 2 sine x plus 1 equals 0. So it's a higher question, but it does involve a lot of techniques from previous levels and previous material we've covered. So we have to be able to recall these ideas and these techniques that we've covered. Yeah, it might have been a few years ago, but we still need to be able to do it. Now this question here is worth 5 marks. Your first mark is for knowing the correct substitution to put in. Second mark is for then rearranging it and getting ourselves a quadratic. Third mark is for effectively factorising that quadratic. Fourth mark is for getting your 2 equations that occur here. And then the 5th mark is for getting your solutions that occur. Now, one thing to note is that the answers for 4 and 5, so when we get our 2 little individual trig functions and their solutions, these can be marked horizontally or vertically. So let's say, for example, I wrote down 3 sine x minus 1 equals 0, or 2 sine x plus 1 equals 0. There's mark 4. Let's say I then solved one or both of those wrong. I wouldn't get mark 5. However, let's say I said 3 sine x minus 1 equals 0, or 2 sine x minus 1 equals 0. I'd obviously got one of those functions wrong, one of those equations wrong, so the 2 sine x minus 1 equals 0. I would lose mark 4. However, I actually still could gain mark 4 if I solved the 3 sine x minus 1 equals 0 correctly and got 19.4 and 160.6. So like I say, it could be marked horizontally or vertically for these types of questions. So just because you make a mistake on one line doesn't necessarily rule out 2 marks overall. You still could get it. So bear that in mind when we're working with it. Now, as I've said, it is a lot of maths that's been thrown at you there. It's a lot of techniques. It's a lot of numbers and trig stuff. It looks more complex than it is. I promise it is. Once you get down the habit of firstly eliminating your 2x in one of the functions, so cos 2x in this case, or if it had a sine 2x, eliminating that. Once you get in the habit of eliminating that, writing the whole thing in terms of one trig function, manipulating it to be a quadratic, and then solving it using quadratic techniques, realizing how many solutions that we get and getting them all, we actually will be able to nail this one with a little bit of practice. But once you get the practice in, once you know exactly what you're doing, you'll find that it is a lot more simple and straightforward than you'd think, and it'll eventually become easy peasy, lemon squeezy.